Hi class, in this video we're going to talk about repetition statements. Repetition is to repeat, which implies looping statements and looping structures. So that's what we'll be looking at here in this video. It all starts, of course, with the condition, like in an if statement. An if statement has a condition that evaluates to true or false. The loop is also based on a condition. So we take that if condition and we convert it a little bit and make it responsible for whether we're going to continue repeating execution of some code. So in this flowchart, we input some data, we make a decision. If the decision results in a false situation, we repeat and we keep repeating. When our decision finally results in a true condition, we stop repeating. So we can have a loop that's based on a condition. In this flowchart, again, we input data, we have a decision, and we say if the decision is true, we want to execute some sort of process. And that's our basic if statement. So notice the looping structure where we can continue repeating some sort of loop body, just like we have an if statement body or a method body, like in our main method. And we can have that enclosed with curly braces. So our test condition for a loop is just exactly the same as our test condition for an if statement. It results in a true or false value. We use the relational operators less than or equal, greater than or equal to, and is not equal to. So when we're looking at our condition, just like when we're forming our condition for an if statement, our condition must have two sides, like if A equals B. A is one operand or one side, B is the other operand or the other side. Our operands could be literal strings or values within the code. That's fine. Whenever we're working with loops, certain terms are very important. An iteration is one execution of the body of the loop. The loop body is that code that will execute if the loop condition is true. So it's the code contained within the opening and closing curly brace. An infinite loop is a loop that never ends, and that's a bad thing. We don't like that. Now we can have some different types of loops. First of all, the pretest loop. In the pretest loop, we check a condition, and if the condition is true, we execute the loop body. Then we check the condition again. If the condition is true, we execute the loop body again. So we'll keep repeating that until the condition is no longer true, at which point we'll continue on executing code after the end of the loop body. This is called a pretest because we are checking our condition before we execute the loop body. Here is some code that would be Java oriented for this kind of test. We are setting up a scanner, prompting for a number, reading in the number, and while the number that they enter is not equal to 5, we're going to continue asking for a number and reading one in. We'll go back to our while loop. When they finally enter 5, right, then that condition, oops, what am I saying there? When they finally enter 5, it'll be done. Is that true? We got a negative there. That's always bad. And so I do that on purpose because I wanted you to really notice how that not equal can make things kind of confusing, because oftentimes beginning programmers will use the not to clarify in their minds, but it actually causes more confusion. So we're saying that we input a number. If that number is not equal 5, we're going to execute our loop. When it is equal 5, we'll output that. So some things about our while loop. The while loop is formatted with this syntax, while. Our condition is within parentheses. We have an open and closing curly brace that contains the loop body. And this is the code that will be executed if that condition is true. Now we can use a shortcut. If we only have one line of code in our loop body, we can eliminate the opening and closing curly braces. Convention says that our loop body should be indented. so that we can easily tell that it's part of that while loop. Now this is an example of a post-test loop. In a post-test loop, we execute the loop body, do something, and then check a condition. And if the condition is true, we execute the loop body. So in our post-test loop, the loop body always gets executed at least once before we test that condition. So here's an example in Java. In Java, we would implement that with a do-while loop. So here we could say, output this message, please enter a number. We'd read in the number. We'd want to do that while the number is not equal 5. So the first time through, we would execute that loop body. We would test the condition, and then if the condition were true, we would jump back to the do and execute the loop body again. When we fall out of the while loop, we'll continue on executing code after the while statement. So notice the do-while syntax. We have the keyword do and while, so it's kind of a double there. In between those two, we're going to have opening and closing parentheses, and we're going to have our loop body. At the very end, after the keyword while, comes the condition to be tested to decide if we're going to continue executing our loop or not. Notice that we have no way of not using curly braces for this command because it is so complicated. Now, sometimes we need to nest one loop within another. I don't know if you've noticed, but driving around campus, some of you may not have to if you're all online, but it can be hard trying to park. So while you're trying to park, you might drive through various different parking lots checking to see if a parking spot can be found. And if you do find a parking spot, great, you can quit your loop, right? You can stop checking parking lots and you can stop trying to park. But if not, then you're going to have to keep checking and keep checking that parking lot, and then you'll have to leave that parking lot and check another. It can get crazy. But if you do finally find a parking spot, you can use the break command to terminate your loop to execute or to continue on after your closing curly brace of your loop. You can also use a special command called continue to end this particular iteration of the loop and return to the test condition to see if it should be executed again. So both of these commands are kind of go-to like. They break the course of our code. So they're discouraged, but sometimes they're very useful. Whenever we're working with loops, you may have noticed so far, if you haven't, I want to really clarify, there are 3 steps to controlling a loop. We're going to control a loop with a loop control variable. Before we begin the loop, we're going to initialize that variable, give it a starting value. Then in our loop, we're going to test that loop control variable. And at some point, we want to, within each iteration of our loop, update that loop control variable so that we can end our loop. Otherwise, it would be one of those infinite loops. So when we're doing a while loop, we do those things separately. But a for loop allows us to do all of those things all at once. So it can be a little bit more complicated. We start out with the keyword for, and then within parentheses, our for loop has 3 distinct parts. The first part sets up the loop control variable. In this example, we're going to name our loop control variable I, and it's going to be set up as an integer. We're going to start it with an initial value of 0. So this declaration, this first part of our for loop, will only be executed when our loop is beginning. Notice that at the end of this part of our for loop, we have a semicolon. Then after that, we have the test condition for our for loop. We want to execute this for loop while I is less than 10. So great. Every time we execute the loop, we'll check that value to see if I is less than 10. If it is, we'll execute the statements within the loop body. Again, our test condition is terminated with a semicolon. And then after that, we have the increment or decrement of our loop control variable. So in this case, we're saying that we should add 1 to I every time our loop control is executed. Now we noticed in our previous chapter that when we're using these special operators like this, like plus plus, if we put the plus plus before the I, we need to do some testing, right, to see if it has any impact on our loop. We could also have a minus minus here if we wanted our loop to go down to be a decrement loop, so we can control things however we like. So the for loop is going to declare an integer named I. We could use a pre-existing integer. We don't have to declare it. If we left out that keyword int, we would be assuming that we had a variable named I already in our code to be used. Then we check I against some condition, and finally we update I after each loop iteration. So the for loop can help us structure that. Our for loop again has a little bit more complex syntax. We start out with the keyword for, and then we have all of the for loop control information within a set of parentheses. We declare a data type if we want our variable v to be allocated just for the scope of this for loop, and then we set it equal to an initial value. We end that initialization information with a semicolon. Then we put our test condition, what our variable must equal to continue executing our loop, and then again a semicolon, and then our increment decrement value of our loop control variable. Now our for loop has opening and closing curly braces, and our loop body is indented within those opening and closing curly braces. So the for loop takes care of all three steps of our loop control: initialization, test, and update. So it can be quite handy, but it also can require a little bit more testing on a student's part to get a good handle and understanding on. So be sure you're looking at some practice programs and trying some different things, which we'll do in another video. Now, as a summary for repetition, repetition structures allow us to control our code and keep from having to duplicate code. We do repetition in Java with three statement types: our while loop, our do while, and a for loop. For loops are the most robust, controlling all aspects of the loop within the for statement itself. And again, it's critical to master these different looping structures. Thank you.